So let's talk about the convergence of the alternating series. So previously we talked about the geometric series when the terms of the series are going to be multiplied to the same number, right? In this example, the terms of the series, the first term is 1 over 3, the second one is obtained by just multiplying 1 over 3 to the previous one. So the third one is obtained by multiplying 1 over 3 to the 1 over 9, which is going to be 1 over 27, and so on. So in this case, the general quotient, the number which we're multiplying every time to the terms is 1 over 3 is less than 1, so that is why we can use the formula, which is the first term 1 over 3 divided to the 1 minus the general quotient, which is 1 over 3, right? So this is going to be simply 1 over 2. So in this case we can find the sum. So let's consider another series which is simply minus 1 over 3 in the power of n, right? So which is minus 1 over 3, minus 1 over 9, minus 1 over 27, and so on. So it is very similar to this series, so that every term is multiplied simply to the minus, right? So that is why the sum is also going to be minus 1 over 2. So there is a special case for the series when the sign of the terms are going to be minus and plus, alternating. So minus, plus, minus, plus. So this is the case of the harmonic series when the sign of the terms are going to be minus, plus, minus, plus. So are going to alternate, right? So in the general form, we can write this as the summation n goes from 1 to the infinity minus 1 in the power of n plus 1 multiplied to the 1 over n. So when the signs of the terms of the series are alternating, this kind of series is called the alternating series. So in alternating series, is a series where the terms are alternating positive and negative signs and negative signs. So this is an example of the alternating harmonic series, right? So simply 1 over n, summation of the 1 over n would be harmonic series. Summation of minus 1 in the power of n plus 1 multiplied to the 1 over n is the alternating harmonic series. So if we're given an alternative series, so we're given the alternating series minus 1 in the power of n plus 1 of bn. N goes from 1 to the infinity, where it can be written. So let me write this. It's going to be b1 minus b2 plus b3 minus b4, and so on, right? So the terms of the series are going to alternate its sign, right? So it's going to be positive term, negative term, positive term, negative term, and so on. So that all the bn's are positive, okay? So the signs before the bn's are alternating, but the bn's as well itself is positive number, right? For example here, 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, all of them are positive numbers, but the signs are going to be different, okay? So if we're given the alternating series in this form, we need to check the two conditions. So the first condition is the terms of the alternating series are going to be decreasing, or in this case non-increasing, for all values of the n, okay? So it is not possible that sometimes it is increasing then decreasing, right? It's always going to be non-increasing. So the next terms of the series are going to be smaller or equal to the previous terms. In the second condition, the limit of the bn when n goes to the infinity should be equal to the 0. If these two conditions fulfilled, then the series bn is convergent. So let's do an example. So we are given a series, as we called, an harmonic alternating series. 1 over n multiplied to the minus 1 in the power of n plus 1. N goes from 1 to the infinity, right? So Bn, the general term of the series, can be written as 1 over n. So we need to check the two conditions, 1 over n plus 1 and 1 over n. It is Bn plus 1 and Bn. So it is clear for n is more than 1, 1 over n plus 1 is always going to be smaller than 1 over n, right? So the first condition fulfilled. And the second condition tells me that we need to check the following condition, the limit of 1 over n when n goes to infinity, which is equal to the 0. So both of the conditions are fulfilled. So that is why this series is convergent, right? Even though the harmonic series without alternating its sign, positive series, is divergent, the alternating harmonic series is convergent. So let's consider another example. So we're given a series in this form, minus 1 in the power of n. So 3n divided to the 4n minus 1. n goes from 1 to infinity. So the signs of the terms are going to alternate their sign, right? Minus are going to be alternating. So minus 1 plus 1, minus 1 plus 1, and so on. So we can write down the general form of the series in the form 3n divided to the 4n minus 1. So let's start checking the conditions for the convergence of the series from the second one. So the limit of Bn when n goes to infinity is going to be the limit of 3n divided to the 4n minus 1 when n goes to infinity. So we can just divide everything to the n. So let me multiply 1 over n to the numerator, n to the denominator. It doesn't change the ratio, right? So if you multiply this to the numerator, it's going to be simply 3, and on the denominator it's going to be 4 minus 1 over n. When n goes to infinity, this term becomes 0, right? So that is why the answer is 3 over 4. So which is not equal to the 0. It means that the second condition doesn't work, right? So that is why this series is divergent.